Hi guys, welcome to my channel. Today let us start with exercise 1.4. Let us start. I'll give you a brief explanation about what are rational and what are irrational numbers. Rational numbers, the numbers which can be written in p by q form where q is not equal to 0 are rational numbers. Example, why I am saying q is not equal to 0, when you write 1 by 0, these numbers becomes undefined. These numbers becomes undefined. That's why I am writing q is not equal to 0. Example, 2 by 3, 5 by 7, 8 by 9, etc. Then comes to the irrational numbers. The numbers that cannot be written in p by q form are irrational numbers. Example, root 2, root 3, root 5, root 7, etc. Why I am saying, you have a doubt that why root 4 is not an irrational number, because this is the perfect square, this becomes the value 2. That's why this is the rational number, it is becoming as rational number. That's why. And root 25, take root 25, this also becoming 5, this is also a rational number. You can write 5 by 1. Okay, this is also a rational number. That's why these values does not become true irrational numbers. This value only becomes irrational number. Right, root 2, take root 2, the value of root is 1.414 and continues. This value does not stop and cannot be written in the form of p by q. Take the value root 3, 1.732, this value is also continues, but it cannot be written in the p by q form. That's why these values are irrational numbers and this value is the rational number. Okay, now let us continue with what are co-primes. Co-primes are the numbers, then a pair of numbers which has the common factor as 1. 2, 3, these have the common factor 1. Take 1 into 2, 1 into 2, 1 into 3. 1 is the common factor for this. 1 into 5, 1 into 7. So 1 is the common factor for this. So these are called co-primes. Okay, let us continue with the exercise. Exercise 1.4. Now exercise 1.4. What we have proved that the following an irrational number. This is the, take this. We have to prove this is an irrational number. Okay. Let us assume this is rational number. This is rational number. This is rational number. Okay. This is rational number. Let 1 by root 2 is equals to p by q, where p and q will be the co-primes. So taking like this. Okay, now take the reciprocal of the number. Okay, root 2 by 1 is equals to p by q. Squaring on both sides. Okay, now let us take root 2 by 1 whole square is equals to p by q whole square. Okay, root 2 square is 2, that is p square by q square, that is 2 into q square, that equal to p square. Okay, here 2 divides p square and 2 divides p. Why I am saying p here means, why I am saying divides p means this is the, we have to take as rational number no. So p square by 2, this is rational number. So I am taking like this 2 divides p square and 2 divides p. Okay, this is also a rational number. Take as a rough part for this. Okay, we are taking divides means this is a rational number. That's why I am taking like that. Okay, so 2 divides b square and 2 divides p square, 2 divides p. Okay, take p as 2c. Okay, what will the value of p square? 2 square c square. p square equal to 4c square. Put it in the value of, take this as a 1, take this as a 2, then 2q square equals to 4c square. Okay, where p square value is c square, that 2q square is equals to 2c square. Here also we are taking as I'll rub this. Here also we are taking as 2 divides q square. That means q 2 divides q. Okay, 2 divides q square means 2 divides q. That's why divides by taking, that's the rational number. That's why this is a contradiction. Why this is a contradiction? Because I'll tell this is as a reference. We are taking p and q are co-primes. Okay, but what it has been given to 2 divides, no? 2 divides means it becoming a composite number, no? Composite number. Other than 1 in co-primes, it will 1 is the cofactor, but here 2 becoming a cofactor. So while dividing 2 p by q, then p by q becoming a composite number. So this is the contradiction, no, which has been arised. So this is the contradiction which has been arised. Okay, this is the contradiction arised. This contradiction arises. Why this contradiction arises? We are taking a, why this is contradiction arises means we assumed by p by q as co-primes. Okay, we assume as p by q as co-prime. So this contradiction arises. So root 2 will become a irrational number only. So 1 by root 2 will become irrational number. Okay, I'll explain you this briefly. This we are taking a co-primes, but 2 divides means becoming composite number. Then here we have LHS as a irrational number. What is that irrational number? 1 by root 2. But here RHS becoming rational number. RHS what is becoming rational number? So this is the first statement. Now we here LHS is not equal to RHS. So this is the first statement we have to prove. LHS equals to RHS. But here LHS is not equal to RHS. That is why this is the contradiction which is arise due to our wrong assumption that p by q as rational, 1 by root 2 as rational number. That's why 1 by root 2 will be only irrational number. Let us continue with the second question. All the answers will be the same process, but the questions will be different. Okay, 1 or 2 steps will be different for others. Let us assume this is as a, let assume this number as rational. This number as rational number. Okay, rational number. Root 3 plus root 5 equals to p by q. This is the rational number. Okay, now squaring on both sides. Okay, root 3 plus root 5 whole square is equals to p by q whole square. Why I am squaring? Because here both the values are irrational, so I am taking both the values squaring. Okay, a plus b whole square. This is the formula of a plus b whole square. A square plus 2ab plus b square. Yeah, this is the formula of a square this square. So root 3 whole square. Am I visible? Okay. Root 5 whole square plus 2 into root 3 into root 5, that equals to p square by q square. Okay. Now let us continue. Root 3 square is 3 plus root 5 square is 5 plus 2 root 3 into root 5 root 15 equals to p square by q square. Okay, here this becomes 8 2 root 15 equals to p square by q square. Okay, 2 root 15 equals to p square by q square. Taking this to this side means positive 8 becomes negative 8 minus 8. Okay, root 15 2 root 15 equals to p square by LCM. Take the LCM, 8 q square by q square. Okay, root 15 equals to, take this value down, this is the here multiplication, when it goes to the RHS it becomes division. Okay, p square minus 8 q square by 2 q square. Okay, this is irrational number, but when you write this, it become rational number. So this is the contradiction which has been erased. This is the contradiction which has been erased. This is irrational number, this is becoming rational number. So this is the contradiction which has been erased. So by writing this, what we have says, how means you have to, you can check. Okay, you can check, and this is the rough part. Take p value as 1 and q value is 1. Okay, 1 minus 8 by 2, sorry, 1 minus 8 by 2, this is becoming minus 7 by 2, this is becoming negative rational number. This is 1 minus 8 by 2, this is becoming minus 7 by 2, this is the negative rational number. Okay, so what it has been making, negative rational number. So this is the rational number only, this is rational number and this is the irrational number. So this contradiction arises due to our false assumption that taking p by q as rational, p by q as rational number, so p by q will be irrational number. Let us continue. This contradiction arises due to our false statement. Okay, so root 3 plus root 5 is irrational number. So what you have been proved that addition of two irrational number is also an irrational number. Okay, I'm taking a white blue pen, means this is the rough part. I'll explaining you. Addition of two irrational number will be irrational number. Addition of two irrational will be irrational number only. Okay, with that we have been proved that addition of two irrational number will be irrational number only. Okay, now continue with the third question. Let us assume this as a, let's assume this number as rational number. Okay, 6 plus root 2 equals to p by q, where p and q are co-primes, which has the common factor 1. Okay, now root 2 equals to p by q minus 6, because this is not the irrational number, so we are taking directly towards the right side. Okay, root 2 equals to p minus 6q by q. okay, where root 2 equals to p minus 6 q by q, means this is irrational number, this is irrational number, and this is a rational number. So here what is LHS is not equals to RHS. Okay, this contradiction arises, this contradiction arises due to our false assumption, due to our false assumption. So what we will say, 6 plus root 2 is irrational number. Okay, why I am saying this, because check once this. Okay, put here p is equals to 1, q is equals to 1 minus 6 by 1. What will be the answer? Minus 5. This is the rational number, no, which have the rational number, no, negative rational number also, it is becoming a rational number, no. That's why this is an irrational number. So what we have proved with that means, addition of rational number plus irrational number will be the value irrational number only. What we have proved here, that additional of rational plus irrational number is becomes the irrational number only. Okay, third question, which is the value of root 5. Fourth question, which is the value of root 5, you have to prove and comment me the answer. I'll explain you the fifth question. Okay, let us continue with the fifth question. Okay, let us assume this is the irrational number. Let assume this is a rational number. Okay, so equate this to p by q, where p by q are equals p by q, where p by q, p comma q are co-primes. Okay, so take this 3 plus 2 root 5 equals to p by q. So take 3 to this side, means plus 3 becomes minus 3, p by q minus 3. Okay, take the LCM, p minus 3q by q. Okay, take 2 towards this, here multiplication of 2 becomes division here. Okay, root 5 equals to p minus 3q by 2q. Okay, where this is the irrational number and this is the rational number. Okay, this is the contradiction, this is contradiction. Why this contradiction is, this contradiction is sorry, this contradiction is arises due to our false assumptions, arises due to our false assumption that p by that root 2 plus root 3 is the rational. Why contradiction arises? Because we assume that 3 plus root 2 root 5 as a rational number. So because of this assumption, contradiction arises where LHS is not equal to RHS. So 3 plus 2 root 5 is irrational. So proof 3 plus is irrational. This contradiction arises because we are taking like is as a rational, but this is irrational number. Okay, 3 plus 2 root 5 is irrational number. That's why. Okay, let us continue with